Hello everyone. In this lecture we are going to discuss about 10th class topic, chapter number 1st, similarity, practice set 1.2. So within practice set 1.2 we have the first question. Given below are some triangles and lengths of line segments. Identify in which figures ray PM is bisector of an angle QPR. So that we are given here three different types of triangle PQR, and within it the length of segments we have given, and we are verifying actually ray PM is the bisector of an angle QPR or not. So for any triangle, let us we will draw here for a triangle PQR, and suppose we have a PM be the angle bisector of an angle QPR. So as per the angle bisector property we can say that whatever be the intercept made by an bisector on its opposite side QR, ratio of them, that means we are writing now MQ divided by MR is equal to, we have the ratio of remaining two sides of a triangle, that are PQ divided by PR. Once we started from point Q, so strictly we have to start with the Q for writing PQ divided by PR. So once this property should satisfy, that means MQ divided by MR equals to PQ divided by PR, then we can easily say that ray PM is bisector of an angle, we have a QPR. So look at the first triangle carefully. In the first triangle we have PQ value is 7 while PR value is 3, QM value is 3.5 while MR value is 1.5. So that first of all we are finding for the first sub question the value of first ratio. Let us, I would like to consider PQ divided by PR. So PQ divided by PR equals to, PQ value we have is 7 and QR value we have a 3. So there is a no one common divisor in between numerator and denominator. So I would like to call it as an equation number 1. Look at the second ratio. We have a MQ divided by MR. So what is the value of MQ? As per the given figure we have 3.5 and divided by MR we have 1.5. So to cancel out the decimal from numerator and denominator, we have a after one place there is a decimal in case of numerator denominator. So try to multiply numerator and denominator by 10. 3.5 into 10 we have a 35 and 1.5 into 10 we have a 15. Now everyone well known, 5 7s are and 5 3s are, we have a 35 and 15 respectively, so that we are getting 7 by 3. I would like to call it as an equation number 2. Look at the equation 1 and 2, both are having the same RHS, so that we can equate now the LHS. So from equation 1 and equation 2 we are having, once the RHS are same, so the LHS are same. That means we are having PQ divided by PR, that is equals to MQ divided by MR. So once this ratio is equal, so that we can easily say ray PM is bisector of an angle, we have a QPR. Look at the second figure now. We have given again same thing, we have to find the both ratios. You may find firstly the PQ divided by PR or might be the MQ divided by MR. Look at the second sub question. We have a PQ value is 10, PR value is 7, QM value is 8, MR value is 6. So now we are finding for the second sub question, firstly MQ divided by MR value, that is equals to. So look at the figure, we have a MQ to be equals to 8 and MR to be equals to 6, so that we are getting here MQ divided by MR equals to 8 divided by 6. So now everyone well known, 2 4s are we have 8, 2 3s are we have a 6. So I would like to call it as an equation number 2. Now let us try to evaluate PQ divided by PR. So look at the figure, we have a PQ to be 10 and QR to be equals to 7. So I am writing here PQ divided by PR equals to 10 by 7. So there is a no one common divisor in between 10 and 7. So I would like to call it as an equation number 2. Now look at the equation 1 and 2's RHS. we have a 4 by 3 and 10 by 7 that are not equal, so that we are writing here MQ divided by MR is not equal to PQ divided by PR. You may find the PQ by PR first, and after all MQ divided by MR, it isn't matter. So once the given ratio is not equal, so that we can easily say here ray PM is not a bisector of an angle, we have QPR. Look at the third figure now. We have given PQ value as a 9, PR value as a 10, then MR value as a 4, and QM value to be equals to 3.6. So now again same thing, we are finding firstly the value for, let it be PQ divided by PR equals to. So what are the values of PQ and PR? We have a 9 and 10. So that there is a no one common divisor in between now 9 and 10. So I would like to call it as an equation number 1. Look at the next ratio, we are having MQ divided by MR. We have given already MQ value is 3.6 and MR value is 4. So that we are writing 3.6 divided by 4. So to cancel out the decimal from numerator, in case of numerator we have after one place there is a decimal. So to cancel out decimal, try to multiply numerator and denominator both by 10. So 3.6 into 10 we are getting 36.0, means a 36, and 4 into 10 we have a 40. Now both numerator and denominator are divisible by 4. 4 9s and 4 10s. We have a 36 and 40 respectively. I would like to call it as an equation number 2. Look at the equation 1 and 2's are RHS that are exactly same or identical, so that we can write here the LHS are equal as per the equation 1 and 2. PQ divided by PR equals to MQ divided by MR. I would like to give the reason from equation 1 and 2. So once that ratio are equal, so that we can easily say that ray PM is a bisector of an angle, we have a QPR. So hence here we have the first question. Now look at the question number 2 from practice set 1.2. In triangle PQR we have given the figure PM equals to 15. So I am plotting whatever be the lengths we are given on the figure. PM equals to, we have a 15. Then overall PQ we have to be a 25. Then next to it we have given PR equals to a 20. So look at the PR. Overall PR we have as a 20. Then next to it we have a NR equals to 8. Look at the NR equals to 8 we have given. State whether the line NM is parallel to the side RQ. Give the reason. So once we have to prove that for any triangle PQR NM is parallel to QR, that means we are using here converse of basic proportionality theorem. So what does it told us? It told us once the ratio of intercepts made by the line NM on PR and QR are in equal proportion, then we can say that NM is parallel to QR or RQ. Look at once which are the intercepts made by the line NM. So line NM made the intercepts on side PR are PN divided by NR we are writing, and that is equals to now the intercepts made by the NM on PQ, that are PM and MQ. So once those two ratios are equal, then we can easily say that NM is parallel to RQ or QR, you may write. So first of all, try to evaluate those ratios are equal or not. So for that we will require the value of Pn and Mq. So how to find the Pn and Mq? So look at the figure. We are writing here Pn are the points of collinear, and the point of sequences of the form P after N after R. So that we can easily find now the Pn value, Pn to be equals to overall PR minus of NR. So that we are getting here 20 minus of 8 as a 12. So we are having Pn value becomes a 12. Now try to evaluate the value for MQ. So how to find the value for MQ? Look at once we are having the point P, M and Q are the collinear point, and the point of sequence is like that P after M and after Q. So that we can write now the MQ to be equals to overall PQ minus of PM. We have the PQ value becomes 25 and PM value becomes a 15. 25 minus of 15, we are getting here a 10. So MQ equals to 10. Now once we have Pn and MQ values, so try to evaluate the first ratio. We have it is of the form Pn divided by Nr. So try to consider the ratio. So what are the values of Pn and Nr? Pn equals to, we have a 12, Nr equals to 8. So let's try to use the divisibility. We have a 12 and 8 having the common divisor as a 4. 4 3s are 12, 4 2s are 8. I would like to call it as an equation number 1. Now look at the second ratio, Pm divided by Mq. So now try to consider the second ratio. We have a Pm divided by Mq. So what is the value of Pm? Look at here, we have already given 15 and MQ value we have a 10. So 15 divided by 10. Now everyone well known, 5 3s are 15, 5 2s are 10. So I would like to call it as an equation number 2. Now look at the equation 1 and 2 carefully. Both are having the same RHS. So I am writing here the reason from equation 1 and equation 2. We are having now, once the RHS are equal for both equations, so their LHS are equal. So Pn divided by Nr to be equals to, we have a Pm divided by Mq. So once those ratios are equal, means those intercepts made by the line Nm are in equal proportion, so that we can write here the segment Nm is parallel to side, or it might be the segment RQ. So hence we have our proof. Now look at the third sub question is in the practice set 1.2. We are having in triangle MNP. Already we have given the figure. NQ is a bisector of an angle N. Look at the angle N and NQ be the bisector of it. That's why the same symbolic representation is given. If Mn equals to 5, then Pn equals to 7, MQ equals to 2.5, then try to find out QP. So I will provide the question mark over a QP. So once we have given here ray, which ray we have given, supposed to be, or the segment you may write. Once we have the NQ be the segment, arrowhead is not provided, so we may write the segment NQ is bisector of an angle. We have a N means what? M and P. Try to read the angle in terms of 3 capital letters, or P and M you may write. So once we have given the bisector, so I am writing here by angle bisector property. What it told us, the angle bisector property. For any triangle, suppose we have given the NQ be the bisector of an angle MNP. So whatever be the intercepts made on the opposite sides of an angle N, that means we are having here PM be the opposite side. So the ratio of that intercepts, that means we are having QP divided by MQ, that is equals to the ratio of remaining two sides. So we started with the point P, so that we are having Pn divided by Mn. Let us try to replace all values whatever we have given as per the figure or the given data. So QP we are finding, MQ value we have given as a 2.5, Pn value we have a 7, and Mn value we have a 5. So try to be shift now 2.5 from LHS to RHS, so that we are getting the value of QP is of the form. Now 2.5 is the divisor, after all shifting it becomes a multiplier. Multiplier to whom? To 7. Keep in mind. Whole divided by we have a 5. Now to cancel out this decimal point, we have the decimal point after one place in case of numerator. So try to multiply and divide simultaneously by 10. Once we have the decimal after one place, so that we are getting 7 into 2.5 into 10 becomes 25.0, means a 25, and 5 into 10 in case of denominator we have a 50. 25 ones are 25, 25 twos are 50, so that will remain with the 7 by 2. So after all dividing 7 by 2, we are getting 3.5. So QP value we have a 3.5. Now look at the fourth sub question within a practice set 1.2. We have measures of some angles in the figure are given. prove that AP divided by PB equals to, we have a AQ divided by QC. Look at the AP, then PB, then AQ and QC. That means ultimately we have to use here basic proportionality theorem. But for basic proportionality theorem, firstly we have provided that the segment PQ must be the parallel to the BC. So try to prove that firstly the PQ is parallel to BC. So how we can prove the segment PQ is parallel to the side or segment BC? So once we have given here angle APQ which is congruent to angle ABC. Why? Because both are the 60 degree. And look at those two angles that are formed is in the rotation of F. So they are corresponding angles. So I am writing by converse of corresponding angle. So we have given the angle are congruent. Then we can write the lines are parallel. Once the lines are parallel, then we can say that the angles are congruent. This is the corresponding angle theorem. Now we are having that angles are congruent and we are proving the lines are parallel. That means we are using converse of corresponding angle theorem. Keep in mind between the converse and the theorem. So what it told us, once the angles are congruent, then we can say that the lines are parallel. Means we can write here segment PQ is parallel to segment or side of the given triangle BC. Once the PQ is parallel to segment BC, so that we can write by basic proportionality theorem. Basic proportionality theorem. We are having here whatever be the intercepts made on line AB and AC that are in equal proportion. Means we can write the intercepts are of the form AP and PB, and next side having the intercepts AQ and QC. So that are in equal proportion. Hence we have our proof. Look at the proof. We have to prove for AP divided by PB equals to AQ divided by QC. Look at the fifth question within practice set 1.2 in a trapezium ABCD. So once it is the trapezium, we have one pair of opposite side is parallel. Look at the figure, AB is parallel to ultimately CD. Once it is a trapezium. Side AB is parallel to side PQ is parallel to side DC. That means all three lines we have given the parallel. AP equals to 15. So that we are given AP equals to 15. PD equals to we have a 12. Look at the PD equals to we have a 12. QC equals to 14. So I am writing the QC equals to we have a 14. And next to it we have to find for BQ. So I am putting the question mark over BQ. So what we have now, once the three lines are to be parallel, so that we are having here side AB is parallel to side PQ, or segment you may write is parallel to side DC or CD. So once three lines are parallel, so by the property of three parallel line and their transversal, so that implies ultimately the segment AD and segment we have a BC are transversal. What is mean by the transversal? Once a line intersects the parallel line, then that line itself said to be the transversal of given parallel lines. So AD and BC are transversals. So we have the property, I am writing here by the property of three parallel lines and their transversal. Parallel lines we have and their transversal. So what does this property told us? So it told us about the intercepts made by the transversal within a parallel lines that are in equal proportion. That means we can write here AP divided by PD equals to we have BQ divided by QC. So let's try to substitute whatever be the lengths we have given for the segment AP, PD, BQ and QC. So AP becomes a 15, PD becomes a 12, BQ we have to find, and QC equals to a 14. So for finding the BQ value, try to shift the 14 from RHS to LHS, so that we are getting for 15 into 14 divided by 12 equals to BQ. Now everyone well known, 2 sevens are we have a 14 and 2 sixes are we have a 12. So that 15 sevens are we have a 105. So I am writing that is BQ equals to we are getting 105 divided by 6. So try to divide 105 by 6, we are getting 17.5. So that here we have BQ value becomes a 17.5. Look at the next question number 6 within practice set 1.2. Find QP using given information in the figure. So already we have given NQ be the angle bisector of an angle MNP. So I am writing here at start the segment NQ bisects an angle we are having MNP. Once the symbolic representation is same, so that we have given already M and Q is congruent to P and Q. So ultimately segment NQ be the bisector of an angle M and P. So once it is an angle bisector, so that we can easily use here by angle bisector property. So what does it told us, the angle bisector property? Whatever be the segments made on the opposite sides of an angle N here, so that are in proportion with the remaining sides of the triangle. So by angle bisector property, we are having MQ divided by QP equals to MN divided by NP. So try to replace whatever be the known segments we are having by their value, so that we have MQ to be equals to given on the figure 14. Next we have to find for the QP here, so keep that QP as it is. MN equals to we have a 25 and NP equals to we have a 40. So once here QP is located in case of denominator, so taking reciprocal on both sides. How to get the reciprocal of any rational number? Let's try to interchange the numerator and denominator of the given rational number. So that taking reciprocal on both sides, we are getting here QP divided by 14 equals to 25 divided by 40. So that for finding the QP value, let's try to shift the 14. We are getting QP equals to 25 into 14 divided by 40. Now 2 sevens are we have a 40 and 2 2s are 4 with 1 0, that means 22s are we have a 40. So 25 into 7 we are having 175 and divided by 20 as it is. Now both numerator and denominator are divisible by 5. We have a 5 3s are 15, remainder is 2. It generates a 25, so 5 5s are 25, 5 4s are we have a 20. So that we are getting here 35 divided by 4. So try to divide now 35 by 4. We are getting QP to be equals to 8.75. Hence we have our answer as a QP 8.75. Look at the question number 7 from practice set 1.2. In figure 1.41 we have given the figure. If AB is parallel to CD is parallel to EF, then find X and AE. Look at once we have CE becomes a X and AE means overall AE we have to find. Now once we have given here AB is parallel to CD is parallel to EF, so that we can write here the line AE and line we have a BF are transversal, because that are intersects to three parallel lines are transversals. So once we have the three parallel line and it's a transversal, so we have the property by the property of three parallel lines and their transversal. So what does this property told us? So we can write whatever be the intercepts made on the transversals that are in equal proportion. Transversals. So that here we are having now BD divided by DE DF, that is equals to BD divided by DF, that is equals to AC divided by CE. That means we have a AC divided by CE. Now replace whatever be the known values we are having. BD becomes 8, DF becomes a 4, next to it AC becomes a 12 and CE becomes a X. So once we are finding the X and X is located in case of denominator, so taking reciprocal on both sides. How to take the reciprocal? Let's try to interchange the numerator and denominator of given rational. So both side. So we are having 8 by 4 whose reciprocal becomes 4 by 8. We are having 12 by x whose reciprocal becomes x by 12. Now everyone well known, 4 ones are 4, 4 twos are we have a 8. So that we are getting half equals to x divided by 12. So that should implies now the value of x becomes, try to shift the 12 from RHS to LHS, so that we are getting here 12 ones are 12 divided by 2 as a 6. So that we are having x is equals to 6. Now we have to find the value for AP. Therefore, we have to find the value for AE actually. Look at the figure once carefully. Once the point A, C and E are collinear, lie on the same line, so that we can write that the AE as a AC plus CE. AC already we have given as a 12 and x value we have now the 6. So we are writing now once the point of sequence is of the form, that means ACE are collinear, then we can write now AE equals to AC plus CE. AC value we have given as a 12 and a CE value we have a x, where x we have now the 6, 12 plus 6 becomes 18. So that we are getting A equals to 18. So hence here we have the practice set 1.2. Thank you.